a few words in Russian for Russian colleagues. Сегодня у нас доклад Тима Весала из Финляндии, посвященный, ну, собственно, зачем я говорю, когда все написано на экране. Обычно у нас мы вопросы задаем лишь только после того, как будет сделан доклад. И лучше всего, когда задающий вопрос покажет себя по видео, потому что все же беседовать, так сказать, докладчику с черным квадратом не очень хорошо. Может быть, Виктор Степаненко сейчас скажет несколько слов о нашем докладчике сегодня. Виктор.
Да, Василий Николаевич, конечно. Dear colleagues, so I would like to very shortly introduce our speaker today, but before that, I would like to note that so we have here our seminar, which is devoted to mostly modeling of the climate system, of the Earth system. But we know that our Earth system is a multi-component system, and it contains not only atmosphere and ocean, but also the land surface systems. And if talking about ocean and atmosphere, we can at least say that we know the basic equations describing the dynamics. This can't be said for the land surface ecosystems. And they are crucially important and as always for the climate dynamics. And in this sense, we are very much dependent, I would say. I mean, modelers were dependent on the people who work with data, the measurement data on the net ecosystem exchange, carbon exchange, and other geochemical cycles linking the land surface systems to the atmosphere, because this data is very important for constraining our models and to make them better. And so from this scope, our today's talk, I think, is very interesting and important. So we have today Timo Vesala, the professor of University of Helsinki. And also you can see on the slide that he is a member of an R Institute, new structure in the University of Helsinki. And he is very well known for many works on the interactions between different ecosystems and the climate system. I mean, of course, forest, I mean, water systems, lakes, rivers. And so I would also, it's my pleasure also to note that Timo Vesala is a very well-known expert, not only in the ecosystems that I just mentioned, but also in one more ecosystem, which is especially important for Russians in the Finnish, I mean sauna. And if you make a Google search, you can find papers by Timo Vesala about physics of Finnish sauna. So I don't know if he is going to talk about that as well, but this is just a small funny thing to note as well. So this is, I think, everything I wanted to say, and maybe we can start.
Okay, hello everybody. I hope I'm heard, and thanks for Victor for invitation, and also for the very nice introduction of me. So the best, if not the best way to introducing me. And you also mentioned important things, not only sauna, but also the things what I will telling you, how they are important for validation and verification of models. And I'm not touching very much models here. And my title is quite long. And to be honest, my talk is somewhat in two parts. And the two parts they are linked, but somewhat separated. But I wanted to go with this kind of little bit like a two-part talk, because I have quite much also time. So I'm aiming about for a 1 hour talk. And yes, I'm coming from Helsinki, and working in Institute for Atmospheric and Earth System Research, basically in physics part, but I'm using double affiliation. So I'm also have another office in forest sciences, because I'm a professor of meteorology, but I have been working a lot also kind of ecosystem and ecophysiological processes. And I start from this carbon cycle observations, and I hope that now there should be a new slide, my first slide. Tell me if the slides are not turning.
It's
Okay,
working.
good. And it's working. Here is just a very general picture, and this is the data from the year 2018. So this is not updated, but the numbers are roughly the same still. And this is just showing the global annual carbon dioxide budget in a way that there are the land areas, atmosphere, and oceans. And then the arrows tell the fluxes, the annual exchange rates of carbon dioxide between these different land compartments and human activities. And as you know, humankind is using fossil fuels, and as a result, there is emissions of carbon dioxide. In these units what are here, it's not so important, but these are gigatons of carbon per year. So we are here 9.4. And then there are land use change, which is, for example, very much related to deforestation. And that's producing CO2 about 10% of these fossil fuels, roughly speaking. And then what is important to note is that about only half of that CO2 is in fact remaining in the atmosphere. So about another half is absorbed by land areas, especially worldwide forests, and then oceans. And but if you look these, if you try to estimate and measure, or for example, fossil fuels consumption is very much kind of a recorded activity. So you know quite precisely what is the amount of coming here, combined with the atmospheric measurements of carbon isotopes. So you know what is this anthropogenic contribution. And then if you try separately estimate these things, and then if you add up them, you see that numbers are not really matching. Well, it's not maybe surprising, because of course, as you know, we can't really provide fully accurate values. And the value of this residual, or let's say imbalance, is 0.6 in these units. So compared with this the man-made emissions, which is the order of 10. So this is a quite small fraction, well, less than 10%, which is a little bit matter of opinion whether it's a much or not. But if you compare it with this individual sink estimates, then this imbalance is already quite much. And this is just in a way indicating that, for example, estimating and knowing what is the land sink, it's still very unprecisely known. So this is in a way the starting point. And then there are a lot of different kind of ways to estimate this land sink. And but all of them have their own kind of benefits and own their disadvantages, and also leading to the relatively quite big uncertainty. And now I'm focusing for these different ways to absorb this land sink of carbon dioxide, and especially saying a little bit more on two specific type of the observation methods. this is more or less the full set of some kind of at the moment presently used methods to estimate this sink. And the one thing which should be noticed is that basically if we would know that there are two ways in a way to estimate this sink, you can either just to because there are carbon is stored in biomass, above ground biomass, and then in the soil. So then if you were able to measure the storage change of carbon, for example, if you see that over the certain areas, the carbon storage in the biomass, in the trees, in the soil has increased certain time, then you know that that amount, it acted as a sink for that amount. The problem is that the carbon storages are very, very big compared these even yearly kind of changes. So the change is relatively very, very small, and it's very difficult to estimate accurately. But if you were able to do it, then, for example, then integrating over the time the storage change, you then get the flux over time. So you follow how it's changing. Or then you can also try to directly observe this exchange rate called flux, which is the same as the sink rate. So and there are, for example, in different ways, typically from the air or by remote sensing or some other techniques, and then you can directly measure it. And then here is examples of typical ways to do it. And there is a big range of these different kind of methods and approaches. The smallest scale we are looking the carbon dioxide exchange at the scale of even leaves, individual leaves or plants. And then at the biggest scale, we can use the satellites as a remote sensing. So and then everything between, and then these different approaches, then also they represent different spatial and then also the temporal scales. So you are very kind of plant scale or the whole globe. And I will now, I'm not really talking all of these, but I will just pick up the two which are for me the most familiar, and this eddy covariance, which is so-called flux towers. It represents so-called ecosystem scale, which is the represents something like the order of magnitude of kilometer, kilometer scales, some tens, hundreds of hectares. So then to get the estimates for the carbon sinks. And then there is another scale, which is the so-called tall towers. And I will say a little bit more on those. But then there is one important point, is that those scales, including flux towers, so their scale is quite small. You know, flux tower is operating scale of the order of kilometer. So it's a very, very tiny. So in a way, from the point of view of the landscape, region, not saying anything on globe and the atmosphere, it's like a point measurement. And to get the estimate for the larger areas from this small scale measurements, you used so-called bottom-up approach, which is typically is then a modeling of the larger areas based on these smaller scale observations. And then, whereas if you go to these larger scale observations, then often they may not have very good capability of the discriminate smaller scales. And you may need, again, the modeling, for example, to make the smaller scale estimates. And then you are then talking so-called top-down approach. So these are kind of smaller scale measurements is like the bottom, and then you construct the bigger areas like the whole globe from these by upscaling, or then you have a downscaling from these top-down approaches. Okay, and then if I look some kind of, and there is really, I must stress that there is no any, we can't say that some certain method is the best one. So they are not in a way competing to each other, because all of them are, strictly speaking, measuring different things, at least in the spatial and temporal scale. So they are not providing data which is immediately comparable to between each other. So in that sense also, we can't say which one is the best one. So it's better to use and utilize all possible kind of a method simultaneously than to narrow down the uncertainties. And then if we think that the kind of pros and cons, so then it's important to notice that so that of course every measurement techniques have their own uncertainty. So this is just a reality, but let's mention it. And then also that I already mentioned earlier, that especially if you look the storage changes, and especially if you go to below ground biomass like the roots and organic material and soil, there are huge uncertainties of estimating it, and there are not really really any other method to just to go to field and dig the soil. You can do also something by remote sensing for shallow layers, etc. But this is very laborious and demanding, and because it always, of course, need also some manual work. What comes to eddy covariance? So this is this flux tower where we are measuring directly the fluxes. So that inherently needs homogeneous areas. For example, ecosystems or land surface, flat topography, and a homogeneous vegetation or homogeneous surface, typically over 1 kilometer in every direction. And you know that the nature, typically the land surface, has a tendency to be very heterogeneous. So this is really demand. And then if we go to the remote sensing, also aircraft measurements and really the satellites, they typically, to get really the absolute values accurately, you typically need then in any case some kind of so-called ground truth, in situ kind of observations for validation and kind of a normalization. And then this is also a triviality that all measurement data, it's really something that typically it really needs the experts to post-process it, and really to when you are using some methodology, you really need to know what you are doing, and you shouldn't use some kind of instruments as a black box and blindly trust and rely on the data. And I'm saying that because, for example, I am sometimes a little bit scared that any eddy covariance nowadays is quite much deployed, and and there is some kind of a standard, even commercial packages, and then some scientists are blindly using them, and you may not really have some kind of enough training and education for really what is this method and what you should really know when you are using it. And now I will say something on eddy covariance a little bit more, and I'm not really explaining how it works. So it's a way to measure the direct vertical turbulent transport of heat and energy. Heat like a carbon dioxide, and then typically then it's done about this surface, about the vegetation. So if you want to have for example, estimate by flux tower for the carbon dioxide exchange over the forest stand. You must have a tower which, for example, extends about twice high above the forest, and twice the tower should be as high what is twice the forest height. And then you get the data, and then the kind of strong thing in eddy covariance is that in principle it's quite automatic, and it provides the sink of carbon dioxide or source of carbon dioxide with the temporal resolution of the half an hour, which is the very high temporal resolution. And I show you here one example. This is quite old slide and quite old data, but it still demonstrates nicely kind of strength of eddy covariance. And this is from the pine forest from southern Finland, Hytiala pine forest from Smerty station. And here is from there we have already the 24 years time series, and here's presented the first 10 years plus 11th year, and here is a year. So this is the week. So here is the 1st of January. Here is the last of December, and here is a sink with the sign notation that negative values mean sink and the positive values mean source. And here is a zone. Units are kilograms carbon per hectare per day. So from these half an hour values, we have calculated the daily values. And in fact, in these plots, these daily values are average for weekly averages. And there's a black line with standard errors. So this is the average of the carbon dioxide exchange in these units for the 10 years period. And what you see here, you see that somewhere around April, this pine forest is turning from the wintertime a small source till sink. And then here is the growing season. And then typically somewhere in October, it's turning back to the sink for a late autumn and for the winter. So there is a very clear kind of pattern. And then as a comparison, there had been put the year 2006. And these green bars represent the weekly average for 2006. And what you can see, you see very well here interannual variability, but I want to pick up you two things. So the 2006, the late summer or end of July, early August, it was extremely dry. So it was the driest period ever over this our measurement time since 1996. And what you can see that typically that time, of course, it's still very much summer. So the forest is on the average a quite big sink, but it was so dry that the trees closed their stomates, the openings on the needles, because they brought into preserved water, and at the same time they couldn't up their carbon dioxide. And there is a 1 week in the high summer that this 60 years old very well growing pine forest was turning source of CO2. And then if I go here into autumn, the autumn was very warm. It was very warm. And if you look, there is about a 1 month period when that time there is not anymore very much light, and the trees are really photosynthesizing, so they are not uptaking carbon dioxide. But if it's a very warm, the soil remains also warm. And then this decay of organic material in the soil, it's very, very strongly temperature dependent. And then the soil remained also very warm. And there was a 1 month period when this source rate, the emission from the forest of CO2 remained about double of the long-term average level. And why I'm stressing this, so the strength of the eddy covariance is in fact detecting at the ecosystem scale. So really the larger area of the forest kind of responses of ecosystem to, for example, meteorological changes, or generally any kind of changes in the environment. And there it's a very, very good. And then I would say that the absolute accuracy of the eddy covariance is not so good. We are talking something like uncertainty easily at the annual basis, something like 10 or 20%. But really the detecting changes and responses is very, very, very robust. Okay, and then I show you another example how to use it in the upscaling. So we made a study, some kind of metadata study, meta-analysis. So we collected. This was published about 5 years ago. So we collected from the literature all eddy covariance data over the urban surface. And these are the all cities which we found. And then in Helsinki, there were different kind of land use types. And I was a little bit, I suggested from my PhD student that let us do it, but I was a very, I would say, suspicious myself beforehand that we are not getting anything out of that, because all of these literature data, this instrumentation and so on, they were not really intercalibrated, so they are just the individual measurement sites reporting their data with the footprint, source area kind of information. But we found the annual values for this exchange rate. So here's the x-axis. Here is the rate of carbon dioxide in the kilograms of carbon per square meter per year for this study site. And then we found from the published paper also the fraction, green fraction, vegetation fraction, meaning so that the value 0 means that in this flux tower footprint source area, there was no vegetation. And then number 1 means that it was only vegetation. So then it was park, not really kind of classical urban things. And again, positive value means emissions. And what you see, there is a lot of scatter, but there is a very, very clear kind of still the dependence. So that the more vegetation, smaller emission rates. Well, this is quite trivial. Of course, it is like that. But it was nice to see that these values are very well in a way comparable, and they are really scaling by this vegetation fraction. And what is also noteworthy is that if you think that when there is a more vegetation in urban areas, in cities, the kind of the emissions are smaller, but they are not really smaller because this vegetation would uptake a lot of CO2 per land area compared to the city, because it's a more like a reason is that if you have a vegetation, it's not emitting anything. It's uptaking, but uptaking a little, but it's not emitting, and that's making this emission rate small. Because you see that even the almost fully vegetated areas, they can uptake annually about this amount. So and if you compare it to these emissions, it's very, very tiny fraction. So this is also important to notice here. And then we made a very simple upscaling. We took this regression, and then we take from the MODIS satellite land use data the kind of this vegetation fraction for the areas which were classified as urban areas is the MODIS. And here you should this European map, and then we use this regression and estimate then this carbon dioxide exchange rates for this European area. I'm not saying more on that, but it was just a demonstrating how you can even quite simple way use this other eddy covariance data for upscaling. And then I will say about these tall towers. So that this eddy covariance was an example of this bottom-up approach. So you have a quite small scale measurements, although they are order 1 kilometer, and then you are upscaling. And then you have these tall towers, and how are they operating? So they are not measuring this flux directly. So they measure very precisely concentration, for example, of carbon dioxide, very, very precisely. The demand is order of the 0.05 ppm, when this concentration value at the moment is about 400. So the accuracy demand is very high. And why? I will say it soon. But then okay, I will say it here. So the idea is that you have a tall tower network. So you have a multiple towers over your landscape, over the region, and then you try to measure very tiny concentration differences between towers. And from these tiny differences, you try to discriminate the surface sinks and sources. And the idea is that if there are the differences in surface in the sinks and sources, and that merge to atmospheric transport, it in a way creates the detectable signal by tall towers in the air. So there are gradients of concentrations coming from these. And if you are using the atmospheric transport model in a way to subtracting its role, kind of its contribution to the concentrations, then this detected concentration differences spatially should reflect the differences of sinks and sources at the surface. But there is one fundamental problem, is that mathematically this is inversion problem, and then in a way to estimate from the absorbed concentrations to these surface sinks and sources. But this problem is in practice ill-posed, because typically, for example, globally, you have a few hundreds of these flux towers. And then, for example, you would like to know, for example, that try to estimate the surface exchange rate for the thousands of grid cells. So then you have multiple plays to produce these absorbed observations. Or observe the concentration differences, and then you need also this kind of so-called a priori first guess for the sinks and sources from the process models, and then you are making this mathematical inversion. But this is still very much used way in this estimating the carbon sinks on the surface. And I will skip over this one, and then finishing soon this first part, I will also just in a way advertise and mentioning that in Europe there had been already in operation for almost 10 years monitoring network called ICOS, Integrated Carbon Observation System, utilizing flux towers and tall towers. And besides CO2, it measures also the methane and the nitrous oxide, as at the same time also evapotranspiration, and there are a lot of also the surface ecosystem observations. And it represents very much forest, wetland, arable and grassland areas, also few urban sites, and there is also the one lake site located in Finland, in fact. And as a side note, for example, Victor has utilized quite much in his modeling work the observation from there. So you can also put the flux tower over the lake. And there are at the moment 13 member countries, and head office is located in Helsinki, and carbon portal in Sweden. And then I have another type of also kind of advertisement, is that just to mention you that that there is a just started Russian mega grant. You may notice a funding instrument, and a mega grant which is together with research group, professors Ego Dukarev and Elena Lapsina in Ukraine State University in Khanty-Mansky. And we have been very much involved in that, and this mega grant is to establish the 3 flux towers for wetland and for the forest in this Mukrino site, a measurement site which is nearby Khanty-Mansky. But not more on that. That was just something like to tell you. And then I'm moving this second part of my talk, and in a way, using, for example, flux towers, you really get information on the carbon sinks and sources, and there is a lot of demand for it, not only in scientific community, but also in a way as just and society. And in a way, if anyone, for example, any kind of a company would like to know, or landowner, forest owner would like to know what is this a sink, they could, in principle, even use these techniques. It's still quite expensive and so on, but the future may change it. And then this is some kind of takes me to this forest and forest harvesting, and I will focus on some kind of very fundamental things related to what kind of impact forest harvesting has for the carbon storage and sinks, and then this atmospheric impact, and very kind of let's say schematic level. And then I will take that information, what I'm telling you, how it has been reflected in some kind of societal discussion and public discourse, and also in the political decision making. And I will also warn you that I may use a little bit maybe non-scientific kind of a talk and discussion, and maybe using also some root words. But let's see how it goes. And then starting point is that there is a lot of discussion that forest harvesting and using of forest, its climate impact. And the fact is that if you increase the harvesting of trees, then the carbon sinks and storages, they are decreased at least for decades compared to the situation that the harvesting wasn't increased. And then this is something which is often debated, because there is a lot of people thinking that you really need the harvesting of forest to keep it growing. And I will now tell a little bit more on that. And I show you 2 schematic things. So and illustrating what is the relationship of the sink and storage. So if you have a storage of carbon in the forest, and if it's increasing linearly in time, so this means average constant sink. So in fact, sink is just a time derivative of the storage. Or then if you know the sink, you get the storage change by integrating the sink. And then if we have a case that there is a harvesting, for example, there are 2 times where the forest was harvested. Some amount of the trees were taken away. So you see it in the storage as a change, decrease of the storage. And then if you want to calculate the average sink from that, so you derivate it. And now I don't want to go to the discussion that how you derivate, for example, this part and starting discussion of delta functions and so on. So if I do it a very, very practical, simple way, you can just look at what is the average slope. And if you draw here the average slope, you see that the slope is smaller than in the case of the non-harvesting, which means that the sink is remaining a little bit lower level. And now this sink is called here average net sink, and this is so-called net biome productivity. So it's a combining both the biological sink, growing of the trees, and the sink in the soil, combined it with this removal of the biomass. And then if it's a source, if the forest is source, then it means the decrease in sink. So the sink can be positive and negative. Storage is always a positive definite. And this is the relationship with these. But in the typical discussion, sinks and storages, what are their differences? This is the often confused in the public discussion, and also what is their relationship. And then what is important to notice also is that typically this biological sink, and this biological sink is referring how the forest, when there is not harvesting, is uptaking carbon. And often this harvesting is not really affecting very much of this biological sink, which you can see here that this slope of this storage increase remains approximately same between these harvesting periods. And this gives in a way a kind of illusion for many that you can just take trees away from the forest and everything is fine because the trees are still growing very well. And but then what you are forgetting is that this harvesting means biomass removal, and it leads to the smaller net sink. When the net sink is including this biological sink and so-called non-respiratory losses, which means this removed biomass. And this is something which is very difficult in a way to understand. And also the one thing is that people are often thinking that the forest is just trees. So and the sink is the same that the growth of the trees. And when you use the forest, when you, for example, harvesting it, thinning and so on, you typically keep the forest at the age that the trees are growing very well, for example, around 50 years old in the Finnish conditions. And then you are thinking that the sink is big. But if you really look the net sink and take into account the removed trees, you see that the net sink is still nevertheless remaining lower. And then there is discussion that if you let the trees just grow there very old, then the question is that of course then the growth rates start to decrease, and then this storage start to really bend down, kind of they start to saturate. But typically the forest should be really very old when it starts to affect very much, and even order of the 100 years, the trees are typically growing as well, almost as well as when they are somewhat younger. So this argument is often also coming, and then there is one thing is that there is a definition that the sustainable harvesting is something that the thing is not negative. And for example, often is thought that everything is fine if you are, for example, harvesting forest just as much, very close how much it is growing, so that the net sink is remaining a little bit positive, but very much, not very much, and then everything is fine. And then it's thought that if you are harvesting more than the trees are growing, and then you are creating the negative sink, so the small source, then it's very bad situation. Although in a way quantitatively it doesn't really matter whether you are a little bit above zero or a little bit below zero, for example over the shorter time period. What matters is that how far here above zero you are. So I'm also questioning this the definition of the sustainable harvesting, and especially that you can harvest very close what the forest is growing and still calling it sustainable. It's not certainly sustainable from the climate point of view. Okay, and then I will skip over this slide, and now I come to the kind of second part of the part 2. So this is a public discourse, and the slide which I showed you, I have showed it several times. For example, even in the Finnish parliament, the very kind of in Finland quite and so on, and also in some public kind of talks. And then I will tell you a little bit kind of a feedback what I have gotten, and also from the newspaper journalist and so on. And my focus is really in Finland because this is my experience. And I tell you here a little bit provocative thing, but this is just what happened. Was that I was invited to the small meeting. It was held in Finnish parliament premises, and there were journalists from about 10 newspapers, and there were also a few politicians present. And then at the same day, when I was there in the afternoon, so in the morning, I was reading a leading newspaper in Finland, and there was interviewed Finnish prime minister, that time prime minister, and Jari Sipilä, and he was saying in the leading newspaper that the forest should be harvested so that they sustain as carbon sinks, and this is just bullshit. You know, and prime minister saying that, and I was reading it in the morning in the newspaper, and when I went to give my talk to the journalist, I started it saying that I was reading newspaper in the morning, and I must say that the prime minister was saying and quoted in the newspaper. So if the prime minister doesn't know this is really alarming. If he does and still says so, this is outrageous. And you know that this prime minister came from this central party representing countryside people, And then I've noticed afterwards, in fact, my colleague in one meeting showed me the website of this newspaper representing this Central Party. And there was a journalist from that newspaper there. And then there was a very big headline that the Professor Timo Vesala is saying like that from the Prime Minister of Finland. Okay, that's as a background. And you don't need to pay attention to this, what is written there. And now, because this forest in Finland is so important, we are getting a lot of income from that. And it seems that industrial wood usage and harvesting of the wood still seems to increase. And I have been involved in several kind of, some kind of reports and some kind of even open letters, Finnish climate change panel reports telling about consequences of the increasing the forest harvesting from the carbon cycle and climate point of view. And it's very well known. And what I was illustrating and telling you on this schematic picture, which wasn't really so scientific, but it was simplified, but it's just the facts. They are just the facts. You can't get rid of that. And still, if I look what kind of comments and feedbacks I'm getting, they are very much kind of varying depending on the perspective and the persons and what kind of communities they represent. I have been thanked several times for clarifying complex issues and bringing scientific arguments for this discussion. Also then thanked for participating as a kind of physicist for natural science, this discussion on important kind of topic on complex socioeconomic and a scientific issue and bringing there these natural science things. But then I have been so many times also in a way accused of being very narrow-minded and biased and forgetting economy. Although I'm always trying to say that I'm not the scientist on economy, I'm just telling that if you increase the harvesting of the forest, what is the consequences of the carbon sinks and nothing else. And I'm not ever even saying that I'm against of harvesting of forests, if there are a lot of good reasons for that. I'm just telling that if you do it, what are the consequences? Then even in the best case, I have been accused of being unpatriotic and even dangerous for Finnish forest industry. I would say that I'm even secretly in a way happy on that and proud. So if someone is saying that I'm dangerous for Finnish forest industry, then I think that I may be an important person, but I don't believe in that. I simply don't believe in that. And the best thing is maybe that I have been blamed to be politician, representing green-red values and telling post-truth statements. One of my colleagues even got the email that where someone was telling when he was telling about the same things as me, and he got the email that what the fucking communist you are. So these are kind of feedbacks what scientists are getting if we are putting fingers on something which is kind of important politically and socioeconomically. And then there is some kind of magazine which is kind of representing kind of this forest industry and the forest owners. And there was some kind of article of there some kind of column, small short article written by the kind of association which is representing the Finnish kind of agriculture and forestry circles. And he was saying there, not mentioning, for example, my name, but it was very really directed to me and my colleagues. He said that that kind of things what we are telling, he called it forest Trumpism in this magazine. And then this magazine or this association organized a kind of a questionnaire for the forest owners in Finland. And there was different statements, and the forest owners should say that whether they agree, disagree, or don't know. And there was a statement that harvesting increases the growth and carbon sinks. And 85% of the forest owners agrees or almost agrees with this statement. And this statement is wrong, at least in the time perspective of 100 or 200 years. But forest owners don't know it because they are also in a way brainwashed by the guys like him. And they don't in a way listen scientists. And I'm sometimes, I mean that I'm just sometimes hopeless and feeling that I'm giving up and raising my hands. That take me somewhere. And then what I'm trying to say is that the decision should be based on facts. And if the decision maker, politician or whoever, is saying that although we in consequences and admit the inconvenient facts, we will increase harvesting. And this is fine. I mean that I would say that if it's politically wise to increase harvesting and, for example, ignore climate and biodiversity effect, that's fine. If there are a lot of good reasons, I don't have anything to say it, but you must say it clearly. But there are used arguments, for example, for forest harvesting, that we must do it because it's good for climate and carbon sinks. And this is not true. Arguments should be, I mean that the decision and should be based on correct arguments. And then it's fine. And then there was a hope because there was some kind of decision made in the EU Commission some years ago. What would be this kind of these reference levels? How they would in a way kind of lead the level of forest harvesting, for example, in Finland. And there was a forest industry interview in TV news, and because this decision for Finland was in fact for Finnish forest industry, it was quite nice. I mean that it wasn't leading to the big limitation of forest harvesting. And then this forest industry representative said in TV news, main TV news kind of broadcasting, that this result of the vote will not rescue the world. But he said that he is happy on that because he comes from forest industry. But he was honest. I was very happy on that because this discussion should be by that level, very transparent and kind of honest. Okay, now I'm stopping soon. I have now talked 55 minutes. And then some kind of summary so that if we go back to this part first, observations. So this traditional forest inventories, they also act at a very small scale, but they are also very valuable to giving also some kind of information compared with the flux towers. And then also to helping in this bottom-up upscaling. And then eddy covariance flux tower itself, so it's operating this scale, and also nowadays eddy covariance can be also used for quite many trace gases. And then these tall towers, based on these inversion techniques, they provide this top-down estimates. And then these estimates of smaller areas, they are very difficult. So for example, flux towers and then these tall towers, they are in a way complementing spatially very well each other. And then I come to this harvesting. So also the important thing is this time span. So for example, if I'm in a way warning of consequences of the harvesting, then I'm in a way, at least implicitly, stressing the short time span. For example, this century or just the coming decades. Because then these consequences of a harvesting is very clearly leading to the smaller sinks. But if someone wants to stress the longest time scale, like beyond this century and so on, it's fine, but you should argument why. And then these consequences of the increased harvesting would appear somewhat different, because this time scale is really important and crucial. But for example, if we want to have a situation that there is only 30 years left to the mid-century, and you know that there is an aim to have a neutral kind of a situation concerning sinks and sources, or that we should turn to negative emissions, so the net sinks to keep warming below 2 degrees. So then in this time scale, you should really be careful that beside, of course, trying to reduce fossil fuel emissions, you should also try to keep sinks very high. And in that kind of from perspective, this increasing harvesting, it's not really fitting there. And then this message is very difficult to take home, since there are confusion, mixing of sinks and storages, and often this sink is only seen as a growth of timber of trees, because the basic reason for forestry is not maximizing the carbon storages and sinks of the forest. The purpose of the forestry is to produce the very good quality timber. And this is the completely different thing than the maximizing the carbon storage. And then there is the argument that if we harvest in sustainable way, so that the keeping this harvesting just a little bit smaller than the growth, then they are sinks in any case. But then you are not really looking at the comparing situation whether the sink is small or large. And then the last thing is that people don't really say their starting point. They don't say what is their time span, which things they are looking for, whether socioeconomical things, or really just the carbon cycle or whatever. I always try to tell what is my starting point. And if you start from this starting point, whether narrow-minded or not, then consequences are this. Okay, thank you.
Okay, thank you very much. Any questions? Okay, Timo, please, one question. You have mentioned the mega grant from Tumen region government, and you are leading scientist for this mega grant. Could you please describe some problems which require special scientific and practical attention?
Related this a mega grant, you mean?
Yeah.
Yeah. Can you repeat your question? I didn't fully get it. Can you repeat it?
Could you please mention some problems, scientific and practical, which are especially important for this region, for studying in this region?
Okay. So this mega grant is, as I mentioned, it's in this Hantimansis, Western Siberia, and the Western Siberia, you know that it's a huge kind of a mixture, mosaic of forest and wetlands, and even globally, the natural methane emissions are very kind of important and not very well known. And for example, there are not even very much observations. So this mega grant is really focusing to improving observations in the Western Siberia. Of course, it's a huge area, and if we have the 3 edicovariance towers, it's just the 3 towers in the huge area. But there are not been so far very many observations at all on there by the flux towers. So this kind of a basic scientific kind of a gain, is try to increase the observations of the important Western Siberian plateau related to a carbon cycle, especially carbon dioxide and the methane exchange from the natural ecosystem from the Western Siberia. What comes to this practical things is that this establishing their measurements, it's quite demanding. And one thing is also that you need electricity and so on. And now I know that they are trying to establishing their main power and so on. So this is kind of this kind of a scheme of this mega grant.
Okay, thank you. Any questions, colleagues?
I have 2 questions, Vasily Nikolaevich.
Okay.
Yes. So I have 2 questions. They are linked. The first question. So Timo, you showed many means of measuring the fluxes of carbon and for different spatial scales, time scales. So if looking at this, I would say, in this research area globally, is there a progress over the last years in the reducing uncertainty of the net ecosystemic changes using all of these instruments on global and regional scale? Is there a progress? Is it significant? And what are the ways of further reducing this uncertainty? This is the first question.
Okay, so there is at least a very trivial and a clear way of reducing uncertainty, that these tower networks, both flux towers and tall tower networks, they are becoming denser all the time. So this is of course the narrowing the uncertainty when you are doing this downscaling or upscaling, and also that also leading to a smaller uncertainty. For example, what has been done in ICOS, this European network, so that this instrumentation and data processing and calibration and so on, they are more harmonized. So then this comparison of the measurements, and then in a way making some kind of multi-site analysis when they are more comparable, that's also reducing uncertainty. And then I would say that there are also had been much more kind of research and the development for different kind of a data model fusion kind of tools, which I'm not an expert on those, but I would say that yes, there is has been the tendency for the narrowing down in the certainties, uncertainties.
Okay, and thank you, Timo. And my second question is a kind of follow-up of the first one. So in the meteorology and oceanology also, we have reanalysis, which is a kind of, let's say in simple words, a fusion of models and measurement data in order to make the optimal estimate of the physical state of a system, yes, including state variables and fluxes, physical fluxes. I mean, yes, the atmosphere and the ocean. is it possible, or maybe there's already some attempts at the moment to develop this kind of approach for carbon exchange? So when you have lots of data and then you have also models of the land system and ecosystems, and there some kind of combination of some data simulation can be used to reduce this uncertainty of the fluxes which you are talking.
Yeah, I would say yes. I'm not really the best expert on that. So my own personal experience or my research group experience is very limited in that sense. But my general answer is yes. There is certainly is, and it has been even done. Although I haven't been very much involved in those things. But in fact, as you are asking it, I can just tell maybe a little bit as a curiosity that I was involved in one very big application to European Research Council, where exactly this kind of idea of combining flux observations with a model for a complex kind of a terrain, having topography and heterogeneities on your surface where you are making flux towers. So then getting better estimates for kind of demanding situations like a complex surface from the model data fusion. But sadly, we didn't get this funding. But there are that kind of activities going on.
Okay, thank you, Timo. Yeah.
Okay, thank you. Questions, please, colleagues?
Vasily Nikolaevich, there are questions in chat. And
yes.
Timo, you may read a question from Andrei.
Yeah, I can read. There is Andrei is asking. Can you elaborate on how is forest harvesting law is set up in Finland? Okay, I can elaborate. So in Finland at the moment, it is so that a little bit in the past, something like just 20 years ago, I don't remember exactly. So that this kind of using of forest, I mean that the forest owners, what they can do for the forest, it was very strictly regulated, and there was even demand that you couldn't, for example, leave the forest untouched. And but now the law has changed so that you can, in practice, in theory at least, you can use your forest as you like. So in practice, it may not be so clear and easy, but if you are not really if you are guaranteed that there are no any kind of diseases spread from your forest and so on, you can leave the forest even intact. So the law is not really demanding you to make a forestry. And then to put it very simple, and then do government lease forest land or sell quotas for harvesting directly? Well, the situation in Finland is that I don't remember exact numbers, but roughly about 50% of forests in Finland are owned by government, and then another 50% is owned by private forest owners, little bit even more than 50%. And then what comes also to the earlier question, so how this harvesting and usage of forest is appearing, it's a little bit different whether you are thinking the forest owned by government or the private persons, because private persons is also very much looking for the economy. So if you need the money and you own the forest, it's understandable that you want to harvest, cut it, and sell if there's a demand in the industry. And then you can quite freely decide it. And of course, the government also then can have a more also then thinking about this recreation purposes, other kind of ecosystem services. Government also owns the conservation areas and so on. But the situation, for example, in Finland is that, for example, in southern Finland, about 1% of the forest, out of 1%, is in a way natural forests, intact forest, and everything else is managed and used, not depending whether it's a government owned or whether it's the private owned. But whether the government lease forest land or sell quotas for harvesting directly, in my understanding, not really, because they do what government do something with their own forest, and then the private owners, they make their own decisions depending on the owner's own kind of interest and demand of money, etc., etc. And also this harvesting is very much driven also the demand of the forest industry. So that, for example, if the number of the pulp and paper factories is increasing, then it means that there is a more demand for wood, and that would certainly lead also to more to harvesting. And but then the problem is also that whether this wood is available locally there nearby of the factories, and then also it becomes more kind of a problematic. For example, if you need to transport wood for over the hundreds of kilometers, and this is also have also some climate aspect. So I don't know. Long answer for your question, which was not maybe exactly to your question.
Oh, thanks. That was quite exact, because what I was thinking is different in political pressure you need to apply, because if it's a privately owned forests, you have to apply for like broader regulation of forestry, and that's harder than to like just reduce government quotas they sell to.
Yeah.
Thanks. And okay. If I can ask another one. There is a Vasilij, can I ask another one really quickly?
Okay.
Yeah, it might be a bit of a detour, but at least in Russia, quite a hot topic here is so-called coarse wood debris, or I don't know. I think so. You understand what I'm talking about? Yeah. So, is there any ramification on how to use that and how it's allowed to be harvested, also affecting the same way?
Yeah. I don't know if there is really kind of a regulation of that, but if there is, for example, really the timber, quite big, good quality trees taken not really for pulp and paper, not for burning, definitely not for burning. So then taken for making really, the wood materials. So then for whatever trees, even smaller trees for pulp and paper and so on, and not so good quality. So then there are these harvest residuals. So sometimes they are left there, sometimes not, and they may be harvested also, and then maybe, for example, burned for energy production, which is then I would say, if you think there's a climate impact, so the burning of wood, of course, I mean that there's a climate impact. You should always, in a way, compare it also to time scale of decay of these debris in the forest. So if, for example, if it's decaying very quickly, then this burning is not in a way giving so big climate impact, because then it would decay and emit the CO2 in any case to the atmosphere. And this is, of course, if you go really to the very small debris, like small branches and so on and so on. But then what if we go to the more this coarse debris which you asked? So there had been also tendency that, for example, you are not taking stumps away. And stump is staying there. So you are digging up them, collecting, and then burning. And this is really something that I would say that the debatable, because if you leave these stumps there, the stumps stay there maybe even hundreds of years and store this carbon. And if you take the stumps away and burn, it has an immediate climate impact. And also then there are also the issue that the more you take away the residuals, then you are also taking away nutrients and something. So in a way, leaving the residuals there, especially coarse residuals, you are not only keeping carbon storage there, kind of retaining it, but you keep there also maybe nutrients and so on. But there are not any kind of general rule whether the coarse debris is left there or taken away. I would say that it depends, and it's really kind of debated. And nowadays it has been also happy to leave there, for example, some kind of dead trees which are still, staying there for something like for biodiversity reasons, for example, nests for the birds and so on and so on. So you are not necessarily taking everything away.
Yeah, yeah, because last year in Russia, they passed a law that this coarse debris is now like free for all. Like everybody can take it, regardless of whether you want to harvest it or like whatever you want to do with it. So yeah, thanks for the answers.
Yep.
Okay, could you, Timo, comment the message from Olga Kuricheva in chat?
Okay, to reduce uncertainty, towers are needed instead of carbon polygons. Olga, can you specify what do you mean carbon polygons? I didn't get this point. What is carbon polygon?
Yes, carbon polygons are modern topic in Russia to measure carbon on some strange methods. So it was message for Russian colleagues who know about these carbon polygons.
I haven't heard about it. I don't know what is it and why you call it a strange method.
I would not like to do this because it is a strange topic, really.
Okay. So it's something like, okay, so you are in a way, your message is, if I read it now, you meant that these towers would be much more important than
yes.
than the carbon polygons, but you want to avoid this topic. Okay.
Yeah.
Okay. Yeah, I'm also sorry, and maybe I don't need to be sorry, and I warned you beforehand that my second part of the talk, it was quite, well, it wasn't political, but I was also touching some kind of political issues, and I used also coarse language, which I warned you beforehand, but I think that it in a way relates to the discussion, because sometimes the debate and discussion, it's horrible. It's horrible. And in a way, I was using this same vocabulary.
Okay, thank you. Any questions, colleagues? No questions. Okay, thank you very much, Timo, for very nice and very interesting lecture. And hope that in the future we will also have some contacts and some additional lectures, especially from your experience in Muhrina site.
Yes.
Okay.
Yeah, I would be happy. Yes.
So, okay, the next seminar will be held on 17th February, and Alexander Baklanov will give the lecture. So please present at this seminar and have very nice discussion. Okay, thank you very much for them, for all of us to participate in this seminar, and especially Timo for very nice lecture. Okay.
Okay, thank you.
Thank you
very
Timo,
much.
very much.
Okay.
Thank all of you.